Hello, in this short video we're going to basically give you an overview of particle systems. Really just about setting the scene here. There will be a separate video that will have a look at a particle system implementation, a simple one in Android, but I want to give you a little bit of background information to that, which hopefully should help by way of understanding the demo. So by particle systems, we're actually incorporating one of the more common, if you like, special effects elements that you have within games. They're very, very broadly used. And we can use a particle system to simulate smoke, explosions, fire, water, sparks, dust, snow, an awful lot of different components within our games. You can see the screenshots here. We have a 3D and a 2D screenshot, and for the flame and the smokes that you see within those, these are particle effects. So they're very often they're used to sort of simulate sort of real-world phenomena, things which otherwise would be quite difficult to simulate using other ways. You can also get them to do fireworks, explosion effects, fancy effects, and it's incredibly broad-ranging what particle systems are used for. You might think that for something that can do all of these different systems it must be complex. Actually quite the opposite. They actually are reasonably straightforward entities. At their heart they have what is known as an emitter. So you've got a particle system, so obviously you've got particles, and the particles are created by what's known as an emitter. It emits particles, and depending upon what you're simulating, you can either emit particles at a constant rate or a semi-constant rate, or in sort of bursts. So if, for example, is an explosion, that's a sudden creation of a number of particles that sort of fly out. If it is, for example, billowing smoke, then you have a constant generation of particles over time. So again, it comes into what type of effect you're looking at simulating. In essence, for the emitter then, we have an update phase and we have a draw phase, as you might expect. In the update phase, we are simulating whatever it is we are trying to do a particle effect for. So we're simulating, for example, smoke, or flames, or fireworks. When we're drawing it, we're going to be simply drawing out the particles that we have within it. When we think about particles, these actually are very simple entities. They are normally represented as a point in space, and on that point we center and draw a single image. For each particle, they're basically, they move. They have a kind of an acceleration, a velocity, a position. They can rotate. They can maybe change their size. They can fade in and out. So it's just basically a simple, moving, transforming object. Now, how particle systems work, and this really comes down to us, is that for the emitter, when it is creating a particle, it tries to balance two things. So for example, if we're looking at, say, smoke, we want to have particles that sort of billow up. So there's a rough direction of travel that things move upwards. But when the emitter creates them, it also has a randomness to this, that when it creates things, sure, there may be a general upwards change or direction of travel, but the speed with which things move up, each particle is given a different value, maybe a slightly different size, a different rotation, a slightly different velocity. And because we have this randomness coming into it, if we're smart about the number of particles that we do and how we arrange them and the values that we pick, we actually then can simulate these effects. So it's nothing more than a semi-random collection of particles, get a lot of them, and then we interpret or we perceive them as being of a certain effect. And we'll see that when we have a look at the demo. So simulation stage, this is, now within the particle, the simulation stage is where you're updating the particle. Basically, you move the acceleration to the velocity to the position, the orientation, things like that. Within the emitter, this is where you can have a more interesting simulation stage. This is where you create new particles and you remove old particles that are sort of exceeded their lifespan. So particles created, then it dies after a while. How you create your new particles or the values you give them does depend on the simulation. And if you look at the explosion effect, reasonably fancy explosion effect you can see on the screen, this is a particle system and it is made up of the 6 images that you see up in the top left hand corner of the image. And if you take a little bit of time to look at the explosion and to sort of look at each bit independently, you'll realize that actually this explosion is made up of lots of simple images that are redrawn on top of one another, maybe slightly different sizes, different positions. Each of those images is a particle. So the emitter for this would have generated a certain number of particles, give them certain velocities, certain speeds, certain directions to simulate, if you like, this particular style of explosion. For rendering it, for drawing it out, normally this is very straightforward. You just got a bunch of particles, you draw them out. Where it can get more sophisticated is that if you have a very, very sophisticated particle system which might have thousands of on-screen particles, you want to draw them out efficiently. And that can get into things like hardware instancing or other related ways of drawing out these images quickly. Particles themselves, as mentioned, it is a single point and we have a single image which we draw on that particular point. And when it works is that we will have a lot of these particles, we'll draw each of them out and we'll combine them together. And by being smart about how we do this or picking the right values, when we add all of these things together, we will have the intended form of visual artifact coming out. Some of the little tidbits on how we need to manage these things. Particles, they are created, they live for a certain period of time, and then they die. We don't want to create a bunch of objects and then discard a bunch of objects. Rather, we want to recycle these particles. So for any system, any emitter generally is responsible for managing, looking after, retaining, recycling, reusing the particles that it holds. Depending on the system that you have, particle systems, you can make them more particles, make more impressive, you can less impressive. You may want to get into dynamic management depending on how much is trying to happen within the scene at the point in time. The order in which you draw them is important. So for example, with an explosion effect, quite often you use additive blending. You sort of have an image where you're drawing lots of these on top of each other and you get a very intense bright color, but as they move apart then they sort of separate from one another and the color sort of naturally decays. For a smoke system, generally it's just a smoky image, you're just drawing normally alpha blending on top of one another. But if you do have something that combines multiple effects, then we have to make sure we do or sort of normal alpha blending first of all, and then additive blending, we add that on afterwards as the second component. We might be doing a effect for a demo. We'll do a particle system that simulates a single effect. That's just by respect of the demo. You can have an all singing, all dancing particle system that can manage multiple effects and multiple different particle setups. It just depends on what you want to accomplish. So overall, particle systems, they actually are reasonably easy to implement. Small number of images that we draw lots of times, semi-random values, we let them evolve. Even though they are reasonably straightforward, they give you a lot of visual bang for your buck, so to speak. So very, very commonly used within a lot of games.